Kathleen skates on a straight track. She starts from rest at a starting line at t equals 0, from 0 to 12 seconds. Kathleen's velocity, so we got our velocity. So this is v of t, but they're calling it k of t. So k of t is our velocity measured in feet per second, is differentiable and increasing. So that means these are always going up. And that means also, since they're always going up, since Caitlin's velocity is always positive, since Kathleen's velocity is always positive, we know that she's always moving which direction? Right. To the right. And we know it's increasing, so since the derivative, the first derivative, is increasing, that means the second derivative is always what? Positive, which means the original function's always concave up. Okay, so that statement alone tells you quite a bit. All right, and the nice thing about it being differentiable, all your theorems work. IVT, MVT, EVT. So if they want to ask for maxes and mins, we can use EVT. If they want to ask that if it goes through a value, like if it goes through 0 or something, we can use IVT. If they want to figure out, if they give you the slope of the secant and they want you to show that there's a place where the derivative is equal to that, we can do that with MVT. So everything applies. Values of V of t are given at various times in the table above. Use the data in the table to estimate. Anytime we want to estimate something, we're either using AROC for a derivative or we're using Riemann sums or trapezoids for an integral. Okay, estimate a derivative, it's AROC, and I actually have that on the Calculus Essentials today. Estimate an integral, it's always Riemann sum or trapezoids. All right, at t equals 4. So I want to estimate a of 4. That is the derivative of Kathleen's velocity at 4 seconds. So to estimate a derivative, we do AROC. So what I'm going to do is at 4 seconds, I'm just going to use these 2 points here. So I'm just going to take 10 minus 5 over 5 minus 3. That's going to give me 5 over 2, and the units would be feet per second squared. And the reason it's feet per second squared is because this is feet per second. And then when you take a derivative, you divide by time again. So it's feet per second divided by seconds, which is feet per second per second. You get 2 points for this. 1 point for the answer, the estimate, and then 1 point for the units. That would have been worth 2 points. And I do have the scoring guideline in front of me so I can get these right. Part B, use a right Riemann sum with 4 subintervals by the data in the table above, which does not necessarily mean the widths are going to be equal. They have not said anything about equal widths, so it could be that the widths are going to be unequal. To approximate, so we approximated a derivative in part A, they're approximating the integral in part B, using a right Riemann sum in RRAM, okay, from 0 to 12, and decide if this is an overestimate or underestimate. Okay, now the fact that it's increasing makes it pretty clear what it is. Okay, if we're doing the area under V of t and V of t is going up, I don't even care how it's going up. It's going up. It might be linear, it might be quadratic, but it's going up. Agreed? Okay, it's always going up. So if I do one rectangle and I do a right Riemann sum, is it going to over or under? Over, because it's increasing. And you'll have to say it's overestimate because it's increasing function. Okay. And this is actually worth 3 points. So your overestimate is going to be because it's increasing. You'll have to say this approximation is an overestimate since the right Riemann sum is used and the function k is increasing. So that would be worth 1 point. You would say because a right Riemann sum is used and the function is increasing. That's your explanation. If it would have been a left Riemann sum, it would be what? Underestimate. Yep. A left Riemann sum would have been decreasing an underestimate because it's a left Riemann sum and it's increasing. You have to say both. You have to say which sum it is, because which sum it is determines if it's going to be an over or under. And then the increasing part also determines if it's going to be over and under. So those two pieces together. And that's all you ever have to say for that. So that is worth 1 point. The other 2 points is going to come from your right Riemann sum approximation, which is from 0 to 12 of k of t dt. And so we're doing an approximation using 4 subintervals. So it looks like the subintervals are just going to be broken up from 0 to 3, from 3 to 5, from 5 to 8, and then from 8 to 12. The first width is what? And then the height is what? So it'd be 3 times 5. They're not going to be equal height. Plus, the next width is what? And then the height is 10, so it'd be 2 times 10. Plus, the next one's going to be 3 times 20. And you don't have a calculator for this, so you're going to have to actually number crunch. And then it's going to be 4 times 24. 4 times 24. All right, and then that actually is worth 1 point right there. Okay, you're showing how you did the right Riemann sum approximation, and I have in my in the answer key it says 1 right Riemann sum with work shown. The approximation, the answer is going to be the other point, and that's going to be when you add all this up, it's going to be 191 feet. The reason it's feet, and it says answer with units. So approximation with units. So if you just had the 191, it's probably going to give you a half a point because you didn't have the units as well.
But if you had the number wrong but feet,
You'd get probably a half a point. And so this is feet per second. And so this is so KT, the height is measured in feet per second. That's the KT. The DT is the width of the rectangles, which is measured in seconds. And so the seconds cancel. That's why it's feet. Okay, part C. Nathan skates on the same track starting 5 feet ahead of Kathleen at t equals 0. So he actually doesn't start at 0 feet. He starts at 5 feet. So Nathan's start point is 5. So that's where he starts from. Nathan's velocity in feet per second is given by this, right? But do not evaluate an expression involving an integral that gives Nathan's distance from the starting line at 12 seconds. So you know he's going to the right. He's going in a straight line. But he starts how far from the starting line? So you got to do start plus displacement. You need to remember that. Start plus displacement. Okay, so if you want to figure out where Nathan is at, his position at 12, how far he is from the starting line, remember he started 5 feet away from the starting line. Then you got to add in his displacement from 0 to 12. So Nathan's, if you want to use S of t, for position, so you would go S of 12 would be Nathan's position at 0, which is going to be 5, plus the integral from 0 to 12 of Nathan's velocity function, which is n of t. Okay, they said n of t is, and so here's how you get the points. You have to know that S of 0 is what? 5. That actually gets you a point, knowing to use the 5. Plus the integral from 0 to 12 of n of t dt, and you actually don't have to write the equation because they gave you a label, so you're allowed to use the label. You can use the label, or you can put the equation in. That is 2 points right there. Done. That's all you had to do. You didn't even have to evaluate. Yes?
Why don't you just set the integral from 5 to 12?
You can't because you need the whole displacement from 0 to 12. You need to know, because he started skating at 0 seconds, so you need to know how far he skated from 0 to 12. And then you need to add in where he started at. So displacement is how far you increase or decrease. So as long as you know where your point starts at, you just figure out how far you increased or decreased with area under the curve. So it's always start plus displacement. Okay, so that is part C. That was 2 points. You got 1 point for handling the 5, and you got 1 point for handling the integral expression area under the velocity to get back to position. Okay, area under the curve always gives you displacement. We're on number 3 on 2015 non-calculator. We're going to try and get through all the 3, 4, 5, 6. Okay, write an expression for Nathan's acceleration in terms of t. So all I have to do is take n of t. Now I might have to do some work by hand. So n of t, all right, they want us to calculate the derivative, write an expression for Nathan's acceleration in terms of time. So all I need to do is actually find the derivative, okay, of this function right here. So let me see. It was 150 over, so it'd be t plus 3 to the negative 1, correct? So I need to rewrite it so I can do the derivative and use chain rule properly. So there's my original function for Nathan's velocity. I moved the t plus 3 to the top. Now I'm just going to take the derivative, use power rule, chain rule, whatever. So it'd be n prime of t. How do I do the derivative of 150 t plus 3 to the negative 1?
Negative 150.
Yep, negative 150 times t plus 3 to the what?
Negative.
T plus 3 to the negative 2.
Minus 50 e to the negative t.
All right, this right here is going to end up being, it's be e to the negative t times a negative 1 because the derivative of this is negative 1. And then when you multiply negative 50 times negative 1, you are correct. You can go straight to positive. So it'd be negative 150 over t plus 3 to the second power plus 50 e to the negative t. And they're not going to have you simplify any further. Like I said, on the free response, you can just leave it like that. They're not going to make you move e to the negative t to the bottom. If you do, it's fine. They'll get it right. That was also worth 2 points. You got 1 point for showing that you knew how to take the derivative, either step 1 or step 2, and then you get a point for writing the final answer. That's it, 2 points, done. 9 points total. How many of you think you could have gotten some of those 9? Okay.
First one.
All right, slope field. I'm teaching this in class today. All we're doing today is calculus essentials and slope field. Slope field is one of those things where it's you kind of have to watch me do it a couple times. So please go back and watch the video. I'm going to be going over the calculus essentials first part of class and some of the integration by substitution problems. And then the last part of class, I'm going to start slope fields. I'll finish it tomorrow with differential equations and slope fields. And then Friday and Monday, I'm going to do volumes. And then I'm going to hopefully be done. Okay. Consider the differential equation dy dx is equal to this. Okay. dy dx is equal to x times y minus 1 over 4. On the axes provided, you get 2 points for this. And I could teach a 7th grader to do this. It's a joke what they're about to have you do. It's free points. All you have to do is use this. What does this represent? What does dy dx actually represent? What does dy dx mean to you? It means derivative, which means what? Slope of the what? Tangent line. A derivative is the slope of the tangent line. So when they want you to, on the axes provided, sketch a slope field, they want you to sketch the slope for 12 different points, the slope of the tangent line for 12 different points. So I'm going to take all of these points, all 12 of them, and I'm going to plug it into the derivative and figure out what the slope of the tangent line would be for each one of those points. That's all you got to do. And how you're going to represent the slope is you're just going to draw little dashes to represent what the slope of the tangent line would be for the original function. So you don't have the original function. You don't know what the original function looks like. And remember, it can be a vertical shift up or down. So you don't even know where the original function would be placed. But what I'm going to do is I'm going to use the 12 points. So for example, let's just start with negative 1, 0. If I plug dy dx, and you don't even have to show this work, you can just do it in your head. At negative 1, 0, I just want to figure out what that slope is going to be. So I'm going to do it. You're probably going to do it in your head. So it's going to be negative 1 times 0 minus 1 over 4, which is going to give you negative 1 times negative 1 on top, which is 1/4. So what you're going to do is make a positive slope that is not very steep. You got to make it look like you're going up 1, right 4. Now, here's the rule of thumb. A 45-degree angle, listen to me, and I'm going to go over this in class today. A 45-degree angle is a slope of 1. Because a 45-degree angle would be up 1, watch this, it'd be up 1, right 1. Do you agree that that's going to give you a 45, 45, 90 triangle? Okay? So a slope of 1, you have to make it look like it's a 45-degree angle. So what are you going to do for a slope of 1/4? Make it less than a 45-degree angle. So you're going to draw a little dash here that is less than a 45-degree angle. That's literally all you do.
Do we draw a graph ourselves?
Huh?
Do we draw the same graph?
You got to do little dashes for all the slopes at all 12 of those points. So you got to do all 12 points. So that's 1 point. Now we got to go to 0, 0. Let's do 0, 0. So if you do dy dx, we're not even trying to find the original function. We're just trying to draw what the slopes of the tangent line would look like on whatever that original graph is at. So wherever that original graph is at, I don't know where it's at, but I know that at negative 1, 0, it's going to have a slope of 1/4 on that original graph. Okay, so 0, 0. This one's going to be really easy because you're going to have 0 times 0 minus 1 over 4. So you're going to get 0 times anything is what?
0.
Well, here's what's going to happen. When x is equal to 0, what's going to happen? The slope's going to be what?
0.
You know you could go straight up now, and all the slopes are going to have to be 0 there. Because anytime x is 0, think about it. If x is 0, you're going to have 0 times whatever is going to give you what? So what you can do is think about what's going to give you slopes of 0 on the top. There's one more place where you're going to get a slope of 0. Can anybody think of where it would occur? If x is 0, you're going to get a slope of 0.
1.
Y is 1. If y is 1, 1 minus 1 is going to give you 0, and then 0 times anything is what?
0.
So you could go a straight across where y is equal to 1 and have slopes of 0 again. That takes care of 6 of the points. Now the other slopes are obviously going to be negative or positive, so I actually got to go figure those out. So let's see what it's going to be at 1, 0. So everybody go to 1, 0. If I plug 1 in, I'm going to get 1, and then 0 minus 1. So I'm going to have 1 times negative 1, which is what? You get negative 1/4. So I need to draw the same thing, but on the other side. So I need to flip the slope less than a 4 and make it look like what you drew before. So it's essentially going to be symmetric, isn't it? I bet you we're going to have something that's pretty symmetric. So go up here. Now, go up here to negative 1, 2. Go up here to negative 1, 2. I can plug it in if you need me to. dy dx at negative 1, comma 2. Let's plug it in right here. So it'd be negative 1 times 2 minus 1. Plugging negative 1 in for x, 2 in for y. Over 4. That's going to give me 1. That gives me what again? That's negative 1/4. So I get basically this right there. What do you think is going to happen over at 1, 2? I bet it's positive 1/4. Let's check it. Just don't just assume. Just check it. And you can do it in your head. 1, 2. Put a 1 in. Put a 2 in. That'll be 1 times 1. Yep, 1/4. That's going to be 1/4. Okay, what is it going to be at the other point? Let's see, 1, 3. If I put a 1, 3 in, so let's do this one right here. 1, 3, put a 1 in. 3 minus 1 is going to be what? 1 times 2 is 2 over 4. Now I need a slope 1/2. Now you need to make it steeper than 1/4. A little bit steeper, but not quite a 45-degree angle. And then what do you think is going to happen on the other side? Negative 1/2. There it is. That's a slope field. Looks like a plotted field. You planted some slopes.
I'm going to X out my graph.
Okay. You have to, and if they do that on the AP exam, that's what you got to be able to do. They only have you draw it on the first response. On the multiple choice, you'd have to pick the slope field that's correct for the differential equation. Sometimes they give you the derivative and you pick it. And today I'm going to show you how you can pick it either from the derivative or if they give you the original equation, what the slope field would be.
So is this what you're teaching today?
Yep. Well, and it gets a little more complicated than that. That's the basic part. That's the basic part. The hard part is actually when you have to look at it and determine what the original equation is from the slope field. That's a little harder. And there's 5 rules to do that. And I'm going to teach those 5 rules today. All right. This next part, you ready? It is worth, part B is this only going to be worth 2 points, and then part C is going to be worth 5. And part C I've got in my thing here. I want you to see it. What does it say there? 0 out of 5 if what?
If no separation of variables.
All right, we're going to show that here in a minute. Part B is easy, though. Part B, it says let y equals f of x be the particular solution to the differential equation. So we don't know what y equals, do we? But we have dy dx. So the particular solution, y equals f of x, would be if I wanted you to go back and find the original equation. All I have is dy dx. I know what dy dx is. I know the derivative is x times y minus 1 over 4. Okay? So let y equal x be a particular solution to the differential equation with the initial condition. So this would let you find your plus c, the 1 comma 3. So the f of 1 is equal to 3 would let you find your plus c if you need to find it. Okay, we've done that. But this is not what it's asking. It says write an equation for the line tangent to the graph at 1, 3. What do you need to be able to write an equation for a tangent line? A point and a what? Guess what? We have the derivative, so can we find the slope? I think we already found the slope at 1, 3. Let's go back up there. What was the slope at 1, 3? 1/2. So we know the derivative at 1, 3. Okay, at 1, 3. Okay, let me see if they actually show this. Nope, they just Yeah, they actually do show the work for this, but you just found it in the slope field, so it won't take you long. So it's going to be 1 times 3 minus 1 over 4, which is going to be, it's going to end up being 1 times 2 over 4, which ends up being 1/2. So there's the slope of the tangent line. You have your point. All right, you get 1 point for the tangent line. Are you ready? Y minus 3 equals 1/2 times x minus 1. That is 1 point. Now, a lot of times they'll actually already have it set equal to y. Remember when I did linear approximation, I had you set it equal to y. So they might, they don't care on the free response, but on the multiple choice, they'll probably have it set equal to y. Because the next part is they're going to ask you to use it to approximate what? So they want you to use the tangent line. So remember, we changed it into L of x. Okay, you don't have to do that. You can call it, I'm going to use this equation to approximate f of 1.4 or L of 1.4, the linear approximation. And so all you do is plug 1.4 in. And this is non-calculator, so Blake's got to be able to do this without a calculator. So he's going to have to go 1.4 minus 1 and say that is what, everybody? And so you got 0.5 times 0.4 plus 3. What's 0.5 times 0.4? Just multiply 5 times 4. What's 5 times 4?
20.
But then there's 2 decimals. There's 1 decimal place for the 0.5. There's 1 decimal place for the 0.4. So there's a total of 2 decimal places. So then, what would it be? 0.2. Because 20, if you move the decimal over twice, it's 0.2. So it's going to be approximately 3.2, and that is your second point. So you get 1 point for the tangent line, 1 point for the approximation. How many of you feel like you could do that? If you could draw the slope field, get the linear approximation, you've almost got half of the points for this free response. Now the last one, you'll get some points doing some stuff, and then you could get like a 7 out of 9 or an 8 out of 9. Because you got to get about half the free response right and half the multiple choice right to pass. All right, find the particular solution to y equals f of x. Now they actually want you to find it. Now they want you to take and figure out what the original equation is. So when they ask you to solve a differential equation, find the particular solution for y equals f of x. Remember, that graph could be, there's an infinite number of possibilities here. Like, I don't know what this original graph would look like, but if I followed the slopes, I might get something that looks like it might be this. Oh, wait, it goes flat there. So I don't know what it could be. It goes flat at 1. So I don't know. If you follow the slopes, it goes kind of flat there, goes kind of flat here, and then here it kind of goes flat again, and here. I don't know what this original equation is. It's probably a hyperbola of some sort. It's probably a double parabola, which is why you have an x and a y in the equation in your derivative. It's not just a dy dx equals an x. So it's not a normal function. It's probably something that doesn't even pass the vertical line test. So it's probably a hyperbola type looking thing. So it's something that's a little bit above your pay grade as far as equations are concerned. But we can solve the differential equation, because all we got to do is take that equation, okay, dy dx. You ready? All right, step 1, you do separation of variables. I taught this like a week and a half ago. Okay, the first step is you separate out the variables. You get all the y stuff to one side, all the x stuff. If you fail to do this, they will give you what?
0.
0 out of 5. If you don't show this step right here. So you have to show, all right, I'm going to move the y minus 1 to this side, and I'm going to move the dx to the other side. Does everybody see what I'm doing? So that's going to give me 1 over y minus 1 times dy. So I'm going to divide by y minus 1. Do you agree with that? Mm-hmm. And then I'm going to multiply by dx. So that'll give me x over 4 dx. That is your separation of variables. Some people might put dy over y minus 1. I don't like to, because I like to see that it's a 1 as a coefficient, because I know I'm going to end up using a natural log there. Okay? So it's up to you. So I like it written like this. You don't have to write both steps. And I actually like this as 1/4 x dx. I think it's easier for students to do the antiderivative when they see it like that. Now, you can go ahead and put your integral both sides. That doesn't mean you didn't separate the variables. Because the next step is you need to solve for the original equation. So I got to integrate both sides. All right, so far you have gotten 1 point for separating the variables. You get 2 more points in a second for doing the antiderivative of each side correctly. So let's start with this side. This is y minus 1 to the first power. Can I move that to the top and use simple power rule for an antiderivative? No, because you can never do an antiderivative with an exponent of 1. Because if you move it to the top, it becomes y to the negative 1. And then if you try and use simple power rule, are you allowed to use simple power rule with y? Like if I had y minus 1 to the negative 1, does simple power rule work with that? No, because when you add 1 back to the exponent, what do you get? And then you have to divide by the new exponent, but can you divide by 0? Simple power rule does not work when you have an exponent of 1 in the denominator. That's when you need what? Yep, natural log. So it's going to be the natural log of absolute value of y minus 1. There is a plus c. Now, let's guess and check this. We actually don't even need integration by substitution, because if you let u be the inside, the y minus 1, du is just going to equal dy. There's nothing to offset, is there? Is there anything you have to offset? Think about it. If you took the derivative of natural log of y minus 1, what's the derivative of natural log of y minus 1? 1 over y minus 1 times the derivative of the inside. But what's the derivative of the inside? What is the derivative of y minus 1? 1. There's nothing to offset. So do you see why integration by substitution is not necessary? Or guess and check? Okay, we did guess and check it. There's nothing to offset. Okay, so that's a simple antiderivative. All right, what's antiderivative of this? You can use simple power rule for this. It'd be 1/2, or 1, you add 1 back and then you divide by the new exponent. So 1/8 plus c. Okay, that's where you put your plus c. Now, what I do, they do it a little bit differently, and it's kind of up to you how you want to do this. They solve for the plus c now. I wait and solve for my plus c. It's just my preference. Okay, but right now you've already got 3 points. You got 1 point for the separation of variables. You got 1 point for this antiderivative. And you got 1 point for this antiderivative. That's 3 points. You ready? And you get 4 points for remember to put the plus c. Okay, so you got a 4th point for remembering the plus c. So you got 1 point for the separation of variables, 1 point for the antiderivative of this, 1 point for the antiderivative of this, and then 1 more point for the plus c. But you only get the full point for the plus c when you actually figure out what plus c is. So you get half a point for putting plus c, and you'll get the other half when you actually tell them what the plus c is. Now, how do you solve this? You got to solve for y to figure out the plus c. And the final point will be actually knowing what the equation is when you set it equal to y. How do you solve this? How do you solve for a log? Come on, I'm doing this with my 9th graders right now. I got a test on it this week. I don't think they're going to do too hot. Come on, how do you solve for a log? Log base 2 of 8 equals 3. Go full circle. What's the base for natural log? E. I did this when I did that CE to the KT, the PERT one. You got to go full circle. So you got to go E to all of this crap is equal to the absolute value of y minus 1. So you're going to have the absolute value of y minus 1 is equal to E to the 1/8 x squared. And if you were with me that morning and I did that PERT thing, do you know what I did here? What did I do here with the power? I said go back to 8th grade. If it's plus, how do you break apart that power? Yep. So you have the absolute value of y minus 1 is equal to e to the 1/8 x squared times e to the what? C. Because if you multiply powers, that's the same thing as adding exponents. Do you agree? So you split the power, because when you add exponents, you can split the power of multiplication. And then what were you allowed to do with this e to the c? You can just throw it out and call it what?
Okay.
C or K or whatever. I'm just going to call it C again. I'll just keep using C's. Yeah, just pick a constant, but I just keep using C's. I'm going to call it capital C now. Okay, because E is a constant, C is a constant, so it's an arbitrary constant. I don't know what it is. And until you find it, you can keep calling it C. Until you plug in that 0, until you plug in your initial value, which was what? you can keep taking these constants and just replacing them with plus c. We already did it once. We did it when we had the plus c here. What did we do? We grouped it with that plus c and just called it plus c. So you're just going to keep calling constants plus c's until you actually plug something in. When you plug something in, then you can't do it anymore. So I'm going to have absolute value of y minus 1 is equal to c e to the 1/8 x squared. Now you can plug in your 0, 1 and figure out.
Oh, still times c?
Yep, times c, whatever this is. I'm just calling it c. Okay, I just put it out front. Might as well just put it out front. Now I'm going to take that point. What's that point? 0, is it 0, 1? Or 1, 3? What was it? 1 what? I can't remember what the heck was the point. 1, 3. That's the point you're going to use. So I'm going to use that point now to find my c. So I'm going to plug a 1 in for, what am I plugging the 1 in for? X, okay? And then I'll put a 3 in for y. What's 3 minus 1? So that's going to, absolute value of 2 is 2. C e to the 1/8 times 1 squared. All right, so that's going to give me 1/8. So I'm going to have 2 is equal to c e to the 1/8. You good with that? Is that correct? So we're going to have c is equal to what?
2 divided by e to the 8.
Got to stop, Siri. C is equal to 2 over e to the 1/8. There's my c value. Okay? Now I can plug it back into the original equation. So I'm going to have the absolute value. Yep, still going. This final point is such a stupid point because you've gotten 4 points probably at this point, but this final point takes forever to get. So I always tell kids, if you don't get the final point, who cares? You got 8 out of 9. It's kind of like the final point is, can you write the final equation? Can you get to the final? If it's on the multiple choice, it's easier than this. But on the free response, it takes some work to get to that final point. That's why this is worth 5 points. Okay, so you got absolute value of y minus 1 is equal to c e to the 1/8 x squared. All right, so what did we say c was?
2 over e to the 1.
2 over, so I'm going to make it, to be fair, I'm going to make it 2e to the negative 1/8 times e to the 1/8 x squared. They would probably count this, but technically here's what they have in their answer key. They've got these e's, and they go back, and since you're multiplying exponents or multiplying powers, what can you do with the exponents? Add them. So you get 2e to the 1/8 x squared minus 1/8. And there it is. And then what they do is they drop the absolute values, and here's why they drop the absolute values. Does anybody know why they have to drop the absolute values? Because when you plugged in 1, what kind of 3 did you get? Positive. So you know that the solution is going to be positive for y, so you can drop the absolute value. And then the final answer, you just add the 1. So it'd be 2e to the 1/8 x squared minus 1/8 plus 1. That's your y equation. And here's how you check it to know you got it right. Like Kristen could go through and say, okay, I think this is my y equation. She should be able to plug in 1 and it equal 3. If you plugged in 1, it should equal 3. It should work with that point that you have when you're done. That's what we're going to work on today and tomorrow.
Sounds fun.
Yeah, differential equations. Okay, let's go to this one.
I got a quit.
Yeah, I know some of you are going to play. So I'm going to keep going. This one right here, number 5, this is actually area under the curve. So I'm going to teach a little preview of volumes and area under the curve. And I'll keep recording. You're staying?
I am. I just gotta go talk to her about it.
Yeah. All right, let R be the region enclosed in the first quadrant. So I got 2 of you. Okay. All right, so R is the region in the first quadrant enclosed by the graph of the square root function. That's the shooting star function right there, Blake. So square root of x. And then x over 3, that's just a line with a slope of what? 1/3. So that's a line with a slope of 1/3. And so we're talking about this region R. Okay, this region R. To find that region R, all you have to do, so if you find the area under the curve, here's the problem. So if I do the area under the shooting star, I get all of that. If I do 0 to 9. So what do you want? What do you got to do if you just want region R?
Set them equal to each other?
Nope.
No?
So that's the area under the shooting. I'm going to do this on.
Oh, wait, do you find the area, or the area under the curve of both?
Yep.
And then subtract one of them?
Yes, you're going to take the area under the top one minus the area under the what?
The line.
The bottom one. And that'll give you what?
The area.
Area between the curves. Anytime you want to find area between the curves, you go the area of the top one minus the area of the bottom. It's literally that simple. I'm going to teach that on Friday. It takes 5 minutes to teach.
Is there ever one where it's like, they like, I don't know what the word is, they like.
Where they intersect and you've got to find another part, then you would have to split the integral. So you'd have the area. So you'd have to do two of them. You'd have to go the area from 0 to 9 of the top one minus the bottom one. But then when you go over here, when you go to this side, the top one switches. So you'd have to go the area from 9 to whatever. So if the shooting star went like this, and the line overtakes it, then I'm not drawing it very good. But if your shooting star went like this, right, and the line goes like this, right, and you want to find that area, then you're going to have to go top minus bottom there. And you'd have to split it. So you'd have two separate integrals. And usually if they do that, it's either going to be on the free response for sure, or if it's on the multiple choice, they'd just have you do setup. They wouldn't actually have you integrate it. We have to actually integrate it and find the area. This is worth 3 points, by the way. This one's going to be worth 3, and it's such an easy one to do. I think it's 3. Yep. So the first point is actually going to be setting up the integral. So if you want to find the area under region R, it's just going to be the area from 0 to, you actually know where you're going to. They actually got the point plotted for you, so you know you're going from 0 to what? 0 to 9. 0 to 9, and you go the top function. Which one's the one on top? Yep, and you actually are allowed to put g of x right here. Minus the area under the other one, which is what? Yep, x over 3, which is h of x. And then actually, if they want you to find it, well, then I actually have to plug in the equations and actually do the work. But this right here would be worth 1 point. So now I actually have to plug in what g of x is. So I'm going to have the area from 0 to 9 of x to the 1/2 power. I'm just going to go ahead and write it as x to the 1/2. Okay. Minus 1/3 x dx. That is all simple to do. So then what I'm going to do here is integrate it. So what rule do I got to use? What rule is it? Simple integral. Do you need integration by substitution, or is it already rewritten? Can I use simple power rule? What can I do? Yeah, add 1 back to the exponent. That'd be 3/2. Divide by the new exponents. That's a 2/3. That's good. Do it term by term. Now do this one. Add 1 back to the exponent. That's x squared. Divide by the new exponent. That's minus 1/6. I can't pull anything out front because it's adding and subtracting. So then you evaluate from 0 to 9. By the way, you've gotten another point. So you got 1 point for writing your integral. You got 1 point for finding your antiderivative correctly. So if you get the 2/3 x to 3/2 minus 1/6 x to the second, that's actually worth 1 point to you. And then the final point is actually doing the FTC part 2. So which number do you plug in first? The 9. So you're going to have 2/3 9 to the 3/2 minus 1/6 9 squared minus 2/3 0 to the 3/2 minus 1/6 0 squared. Well, that's going to be nice because all this is just going to what? What's going to happen to the second part?
Oh, 0.
That all zeroes out, so that's minus 0. 9 to the 3, huh?
That's 18.
Yeah, be careful. Square root of 9. What's square root of 9?
What?
Let me
It's
check.
27, 2/3 is 18.
Yes, good. You're correct. Minus, and then this will be 81 divided by 6, which is kind of a pain. 81 divided by 6, I don't know what that is right now. So I'd have to reduce that and figure it out. And it is non-calculator, so, and they are going to get you down to the simplified answer. I can go with 3 into both, so that'd be 18 minus 27 over 2. Is that correct, if I divide them both by 3? Now the common denominator would be what? 2. So it'd be 36 over 2 minus 27 over 2, which they do get a final answer of 9/2. So that's worth 1 point, or 3 points. 1 point for your answer. So you got 1 point for the setup, 1 point for the antiderivative, and 1 point for the answer. So that's 3 points. And by the way, area between two curves is not only going to show up. Remember I said we're about 90%, 97% of the way there. That's one of the last 3% things that I got to cover is how to do area between two curves. Okay, part B, I'm going to teach you. We're going to learn this on Friday and Monday. Write but do not evaluate an integral involving one or more integrals that gives the volume of the solid generated when R is revolved around the horizontal line y equals 4. I'm going to be doing this Monday and Friday. So here's what they want you to do. They want you to take this region R, and you do not have to know what this looks like to be able to do it. But I just need to explain. So y equals 4 is way up here. They want you to take and rotate this. And if you came that way, I think you were here that one morning when I did this and I said it was discs, cylinders, or were you here?
I wasn't here.
Okay, so what they're actually doing is they're taking this, we're going to learn this Friday. They're taking this and they're rotating it around this. So this area here is getting rotated around it. And it's hard for me to visualize what it looks like, but it looks like one of those things that you throw a coin into, like a funnel kind of thing with part of it.
Yeah.
Like you'd have like a filled-in top and just scoop out all the inside stuff. So all you got left is kind of the funnel itself, but it's kind of warped. It's not a perfect cone funnel. It's kind of curved. You know, it kind of visualize what I'm saying?
Yeah.
Here's the thing. You don't have to know what it looks like to be able to do it. All you have to be able to do is figure out, and here's the deal. You're rotating it around this. So this is your new x-axis. You treat that as your x-axis. So here's what happens is you have if you can represent two rectangles, you can do this. One of the rectangles is the rectangle that would be furthest away from the axis of rotation. Okay, I'm going to teach you this on Friday. You guys are going to get it now and you'll get a little bit ahead. This is called big R of x. That's the outer radius. Okay, why does it end up being a radius? Because we're rotating around something. And if you take a rectangle, think about a rectangle. If you're rotating it around something, what does that rectangle become in 3 dimensions? It's not a rectangle anymore. It's a what? It's almost, not a sphere, but close. It's circular. Cylinder. It's like a hockey puck. Okay? If you rotate this in 3 dimensions, think about it. If I rotate it here, it becomes a tire. Okay? Or a cylinder. Okay? And so that cylinder, the area of a cylinder is pi r squared h, and I'm actually going to give you the formula today to memorize. I'm going to go ahead and give it to you to memorize it, even though we're not learning it till Friday. So the radius actually is the rectangle height. So the radius is actually the rectangle height. So you do this radius here, that's just that height of that rectangle. And then there's also an inner radius. So there's another rectangle. So you got to measure to both functions. And what you have to do is you have to realize there's an infinite number of these rectangles that are getting rotated because the width of these rectangles is approaching what? Remember, when you do area under the curve, what's the width of the rectangle approaching?
0.
0. So here's what happens in the cylinder formula. The height of the rectangle ends up being the radius. The width of the rectangle ends up being the height of the cylinder because this is like a hockey puck. Okay, and it's rotating around, and I'll show you on Friday. I have an animation that shows this. But anyways, what you do is you get an infinite number of these rectangles that get rotated, so they become an infinite number of hockey pucks or cylinders, or what we call discs. Mm-hmm. And so all you've got to do is find the volume of all these discs of the outer one, and then you got to subtract out the volume of these discs of the inner ones. Okay. So here's what it ends up being. So I'll just go ahead and set it up so you can see it. So I'm going to do the inner radius in blue, and I always do a little r. So when I teach you the formula today, I'm going to do big R, little r. Big R is the outer radius, little r is the little radius. So here's the formula. It goes like this. It's volume. There has to be a pi because it's a cylinder, because it was pi r squared h.
Is this question B?
Mm-hmm.
Okay.
This is question B. And you actually get 3 points for it. And it's just all set up. Okay? You get 1 point for the pi. Just remembering the pi. And your limits of integration, which is going to be from 0 to what?
9.
So if you get the pi and the 0 to 9 right, that's 1 point. Now, you get the other 2 points for doing this part correctly. So you got to do the volume of the outer cylinder. So that's going to be r of x squared. And we're going to have to figure out what r of x is. Minus the inner radius squared. So if I can find those out, I get it. I get the point. So outer radius, all you have to do is go top. Remember how we did it? It's top minus what? To figure out this height of this rectangle, it'd be top function minus what?
Minus 1.
Minus the bottom function. So what's the top function, first of all?
4.
So big R of x is top 4 minus the bottom function. What's the bottom function? It's a what?
Oh,
It's that line, x over 3.
or x over 3.
So that's your outer radius. So you go the integral from 0 to 9 of the outer radius, which is 4 minus x over 3 squared. And remember, the direction said write, but do not evaluate. So you don't even have to do anything to it. So there's your outer radius squared minus the inner radius squared. And when you guys see this Friday, you'll be able to get it because you guys watch this. Next time you see this, when I actually show it visually and explain it and give the formula, you're going to be like, oh my gosh, this is actually really easy. It's just top minus what again?
Bottom.
All right, what's the top function again?
4.
Minus, what's the bottom function?
Root x.
Root x. So there's your inner radius. So it's just 4 minus root x squared. And that's it, done. That will calculate the volume if you rotate that sucker around there.
So
It's wild.
It's like coming out.
It's coming out at you. Like, it's 3 dimensions. This sucker is... Like, and I have a program that visualizes it so you can see it on Friday.
Yeah.
It's really cool. And then part C, this does not have anything to do with...
That's the final answer.
Yep, that's it. You get 3 points for that.
Okay.
You get 1 point for the... So this was part B. You get 1 point for this part. You get 1 point for this thing squared and 1 point for this thing squared with the dx. Don't forget the dx. You have to add the dx. They'll probably take like half a point off if you forget the dx.
Why do you need the dx?
Because it's an integral.
Okay.
And that represents the width of those rectangles approaching 0.
When do you drop it?
Never. Until you take an integral.
Like,
If you actually had to calculate this, if I actually wanted you to figure out the answer and actually integrate this, then you would have to simplify this and do your antiderivative. And when you do your antiderivative, that's when you drop dx. When you actually do
so
the
after
antiderivative.
you drop the squiggly line?
Yes, after you drop the squiggly line. Yep. Part C is actually not really the same kind of thing. It says consider. It says find the maximum vertical distance between the graph of H and G. So the vertical distance between H and G, or G and H. Which one's on top again?
Root x.
Yeah, root x, and I think they called that G. So this one's G, this one's H. So the vertical distance is just how far between the two. So that would just be G of x minus H of x. Do you agree? So the vertical distance between the two graphs is just G of x minus H of x. So I'm going to call that, you can call it whatever you want, okay? It says find the maximum vertical distance, we'll call it distance, D of x. And the distance, the vertical distance, is G of x minus H of x. Agreed? That's vertical distance between the two functions. That right there was 1 point.
Okay.
Just knowing that the vertical distance is just G of x minus H of x. Now, if you want to maximize it, maximum, find the maximum. This is EVT. They want you to find the max value. So you need to have a closed interval because remember the EVT, it has to be continuous on a closed. So we know that root x is continuous. Do you agree? Is root x a continuous function? Is a shooting star a continuous function? Is a line a continuous function? I think it was back on page 43 of your continuity stuff. If you add or subtract two continuous functions, do you still have a continuous function?
Yep.
So EVT applies. So here's what you do to do EVT. You want to maximize, you got to check critical values and endpoints. How do you find critical values?
Set it equal to.
What do you got to set equal to 0? Derivative. So you got to find the derivative. So I'm going to take d of x, which is x to the 1/2, and then minus 1/3 of x. I'm going to find its derivative. So the derivative is going to be 1/2 x to the negative 1/2 minus 1/3. And I'm going to set the derivative equal to what? Yes. So there's my derivative. To find critical values, I need to set the derivative equal to 0 or undefined. Now, undefined is easy. Undefined is easy because it's undefined where the denominator equals 0. So real quick, where is it undefined?
Where the denominator equals 0.
Yep, so x equals 0. Right there. Now, they want you to check, when you do EVT, you got to check endpoints and critical values. You're going from 0 to 16. So they want you to go from 0 to 16. So we're already going to check 0 and 16. So you got to check endpoints and critical values, and the largest one will be the max. And you check it in the original function. So you're going to check 0 and 16 in the original function. But you also need to check the critical value. So I'm going to take the derivative, set it equal to 0. So it's 1 over 2x to the 1/2 minus 1/3 is equal to 0. All right, solve that. How would you solve that?
Bring 1/3 over.
Bring the 1/3 over. So you have 1 over 2x to the 1/2 is equal to 1/3. What would you do next?
Bring x to the top.
Multiply by 2x to the 1/2.
Yeah, I'd multiply by 2x to 1/2, or you know what I'd do? Since they're two fractions equal to each other, the quickest way to get rid of fractions when they're equal to each other is cross multiply. That's the quickest way to do it. Or somebody might say, well, can I just bring both of them to the top and do the reciprocal of both sides? Could you do that? Yeah, so I'm just going to do the reciprocal of both sides. I'm going to go 2x to the 1/2 is equal to 3. Bring this to the top, bring this to the top. It's legal as long as I do the reciprocal of both sides. Now I'll divide by 2, so it'll be x to the 1/2 is equal to 3/2, and then what? How do you get rid of the 1/2 power?
Times.
What power would you have to raise it to? Think about it. It's a square root.
Second.
The second power. Because then you have a power tower, and those exponents cancel each other out.
So x equals 9/4.
Yep, so x equals 9/4. You get 1 point for finding that critical value. So now the last point comes from you knowing what is the max. Is it going to be at 9/4? Is it going to be at 0? Or is it going to be at 16? So what you do the candidates test. The candidates test is you test endpoints and critical values. So you got to figure out D of 0. You got to figure out D of 9/4. And you got to figure out D of 16. So you plug into the original. The largest will be the max because they wanted the max distance. So plug in, because remember, did this not represent distance between the two functions? Remember when we subtracted the two functions, was that not the vertical distance between them? So I want to figure out when it's at a max vertical distance. So D of 0, that's going to be, that's the square root of 0. Minus 0 over 3, which is just going to give me 0. So that's 0. 9/4 is going to be the square root of 9/4 minus 9/4 divided by 3. Let's see, that'll be 3/2 minus 9 over 12, which, let's common denominator of 12, so that'll be 18/12 minus 9/12, which is what? Is that 9/12? Which reduces to what? 3/4. Okay, maybe that's the max. And then 16. You get square root of 16 minus 16 over 3. That's going to be 4 minus 16 thirds. And so that's going to be 12 thirds minus 16 thirds, which is negative 4 thirds. So what's the max, clearly? 9/4 is the max. That's where the max distance occurs. Okay, I'll get this last one done, and then we'll call it good. Then I'm just going to be done with this 2015. Do you agree that these are a little bit easier?
So that's the maximum distance in the whole graph.
Between those two functions, that would be the greatest distance. The greatest distance, it looks like it's going to occur about right here somewhere. That's the greatest distance between the two functions.
If I didn't pick one, I just put the CVs, you had to choose one for the greatest. I don't know why.
Yeah, the reason is EVT, it says there is a max value on a closed interval. It has to occur at critical points or endpoints. It's going to have to occur at 9/4, obviously, because you can see at 0 and 9, or sorry, well, they wanted 0 to 16, sorry. So they actually wanted to go past here. So actually, there's more of the function you would have to look at. All right, this last part, number 6 is always easy. You're kind of exhausted at that point. It's always kind of an easy for response. or 5. It's either 5 or 6. One of the last ones they're going to do, you're going to be like, oh my gosh, this seems really easy. Because you're kind of exhausted and they always try and put an easier one towards the end. This one's an easy one, okay? You're going to get 3 points right out of the gate for part A. It says, let g of x be this. Let f of x be the accumulation function. Okay? Find f of 26. So they just want you to find f of 26. What is f of 26? F of 26 would be the area from 0 to x, which we want it to be 26, under g of t dt. Do we know g of t? Do we know g of t? Did they give us g? Did they give us function g? Yep, so all they want you to do is find the area from 0 to 26 of 4x plus 1 to the negative 2/3 power, and they can change them to dx's if you want now. You can change it all to x's. You don't have to use t's anymore. T's, x's, whatever. All right, can I do this with simple power rule? What can you do right away, though? What can you bring out front since it's multiplication? So I can go ahead and bring the 4 out front, and then I'm going to have the integral of this. This is not going to require u substitution, because if I let u equal the inside of the most complicated part, du is just going to equal dx. Is there anything to offset here? Is there anything that you're going to have to offset? Think of it. Does this not require chain rule if you were doing a derivative? So for an integral, it required integration by substitution. But if I let u be the inside of the most complicated part, du would just equal dx. So is there any point to doing integration by substitution? Because I already put the 4 where? Where did I put the 4? So that's done. I don't have to worry about that. The 4 is already out front. So can I just do this with simple power rule in reverse and not have to worry about offsetting anything? Yep, add 1 back to the exponent. What would that give us?
1/3.
1/3, divide by the new exponent,
So 3.
times 3. So I can put that times 3 out front because it's multiplication. And then I don't have to worry about anything on the inside because the derivative of x plus 1 is just 1. So there was nothing to offset. So do you see why you don't have to do integration by substitution? You can just do it with guess and check in your head. Evaluated from 0 to 26. By the way, you have gotten 1 more point because you found the antiderivative. So I'm going to have 12 times x plus 1 to the 1/3 evaluated from 0 to 26. The last point comes from you finding the doing your FTC part 2, which is plug in which number first?
26.
The 26, then plug in the 0. So you're going to have 12 times, it'd be 20, if I plug in 26, it'll be 26 plus 1, it'll be 27 to the 1/3 power, minus 1 to the 1/3 power.
So 3 minus
So it'll be 3 minus 1, which is 2, and then the answer is 24. That gave you a total of 3 points. That's doable. Just plug in 26 and do the integral. Okay. Determine the concavity of y equals f of x for x greater than 0. Justify your answer. So I know that f of x is the integral from 0 to x of g of t dt. That's what this is. That's what f of x is, little f of x. Big f of x would be the original. This is the accumulation function. So they want you to determine the concavity for little y equals, I don't like how they've done this because they're calling let f of x be determined. Okay, so if I want to find, determine the concavity for y equals f of x. Golly, they're saying this is the original function and this is, I don't like this at all. Jerks. Oh, no, that's right. Okay, I just wanted to make sure. All right, so they're wanting to say this is up here, they used little f of x, agreed? So they're saying find the concavity for little f of x. This is little f of x. So how many derivatives do you got to go down to find the concavity for little f of x? Okay, they want the concavity for little f of x. So how many derivatives you got to go down? First derivative would be increasing, decreasing. You got to go down 2 derivatives. So I'm going to have to find the first derivative. So here we go. First derivative of this guy. Okay, first of all, we need to plug in g of x. What is g of x? Your quiz is right there.
Alright.
It's the integral from 0 to x of, what is it? 4 times x plus 1 to the what power? Was it negative 2/3? Correct? Is that correct?
Yeah.
Now, if you do f prime of x, remember the derivative of the accumulation function? When you do the derivative of an integral, all you got to do is plug in what? Let me review the derivatives. FTC part 1. If you do the derivative of the accumulation function from 0 to x of f of t dt, what was the rule? You just plug in what? The derivative cancels the integral, and you just plugged in x. If there was something other than x here, you would have to multiply by the change, but there's nothing other than x. So if I'm just going to plug in x here, is that going to change it?
No.
No. So the derivative is just 4x plus 1 to the negative 2/3. Now we can go to the second derivative. What's the second derivative going to be? Now it's easy. So what would that be? Negative 8/3 times x plus 1 to the what? Negative 5/3? Is that correct? All right, there's your second derivative. Negative 8 over 3 times x plus 1. Hold on. Get the other one. That's not the answer key. To the 5/3. All right, there's your second derivative. All right, you have gotten 1 point for your derivative, 1 point for your second derivative. You get the final point for figuring out, okay, for greater than 0, is it going to be concave or concave down? All right, we only want to know for x greater than 0.
Gave you a spot where it wants you to test.
Huh?
The question gave you a spot where they wanted you to test.
They want you to test for when x is greater than 0. So we know our sign analysis only has to go from 0 to infinity. But I need to see, are there any critical values for the second derivative? Is there anywhere where the second derivative is going to equal 0? Is the top ever going to equal 0?
Isn't it just a constant?
Yeah, it's just a constant, so the top can't equal 0, right?
No.
Is there anywhere where the second derivative is going to be undefined?
-1.
-1. But is that in my interval? Is that in my interval? So my whole sign analysis is just going to be from 0 to what
Infinity.
for the second derivative? All right, ready? Let's plug in a test value. Plug in 1. What are you going to get when you plug in 1? The bottom's going to be what?
Positive.
Positive, very good. The bottom will be positive, and the top is what? Top's what? Negative. So what's a negative divided by positive?
Negative.
So it's always concave what?
Down.
Down. So you'll say it's concave down because the second, you'll say concave down because f double prime is what?
Negative.
Negative. And that would get you the last point.
So is this the first time we've had to explain something
Mhm.
next the entire time?
Mm-hmm. You missed problem 1 and 2. That was a lot of explaining on that one. And it was disaster because in 2015, I did go back and look. There was lots of complaints on this practice exam. What you need?
I was gone yesterday, and then I'm gone Thursday and Friday.
Okay, there's a video and there's packet.
Okay.
Bring it over here and I'll give you a packet. Bring that whole stack. All right, last part, and then you guys, I'm going to stop. Okay, because this will get us done. Let h of x be defined by h of x. This one's also worth 3 points. This one's also worth 3 points. Okay, so 3, 3, 3. So it's straight up.
9 points.
Okay, 9 points, straight up. 3, 3, 3.
I'm gonna master.
Super, super awesome. Yeah, I guarantee I'll have a couple 5s.
Really? I'm gonna get a
Yeah. All right.
Norris, I need a
You
4
said that
to transfer.
Yep,
Jackson
you
was
can get a 4.
going for the 6. Like he's going for it.
He was going for the 6.
That's
He says he feels like he only got like 2 things wrong on the whole thing. All right, let h of x be defined by h of x is equal to x minus f of x. Find the min value of h on the interval from, yep, min value on the there's another EVT problem. Okay? And the only requirement is that it's continuous. Okay? Let h be that x is a continuous function, and they already told us in the directions that f of x was a continuous function. And we know f of x is a continuous function because it's an integral, and you can only do integrals of continuous functions. Okay, because you can't have any leaky area. Okay, so we just need to find, we need to check endpoints and what? Critical values. So we need to find h prime of x. All right, what is the derivative of x? 1 minus f prime of x. Didn't we already find f prime of x in the previous? Yep, go back to part B. Here was f of x. Yep, all you had to do to find the derivative f of x was plug in x because it was the derivative of the accumulation function, so the integral got canceled out and you just plugged in x. So this was the derivative. So you have that derivative already from part B. Sometimes they do that. So you just use that. So it'd be 1 minus 4, what was it?
X plus 1 negative 2/3.
To the negative 2/3. So there's your first derivative. You get a point for that.
Yeah, good job, guys.
1 point for that. Now, actually, you don't get the point until you know to set it equal to what? 0. Then you get the point, sorry. When I set it equal to 0, that's when I get the point. Okay? Now, there is a value where it's undefined. It's undefined at -1 because if you put this in the denominator, but is that in the interval?
No.
No, so you don't have to worry about the -1 being undefined. Okay, what I do need to do is figure out where the derivative equals 0. So I'm going to move the 1 over, and I'll move the 4x plus 1 to the 2/3 over and make it positive. And then I'm going to divide both sides by what? So I get 1/4 is equal to x plus 1 to the negative 2/3. How do I get rid of the negative 2/3 power? What power would you have to raise it to? The reciprocal power. -3/2, because then power tower would cancel it. That'll give you an exponent of 1. You always raise to the reciprocal power. That was from pre-calc.
I would have done 3 halves.
Yeah, you want the negative to cancel too. Negative times the negative is positive. So that gives you x plus 1 to the first, does it not? And then, man, it would be good for people to watch this just on the solving equation stuff. All right, what's the square root of 1/4?
1/2.
What's 1/2 to the third power?
1/8.
And then flip it.
8.
8. Subtract 1, what do you get?
7.
That's 1 point.
Subtracting 1?
Yep. No, forgetting 7. So here's what you got. So far, you've gotten 2 points. You got 1 point for knowing to set the derivative equal to 0. You got 1 point for finding the 7. The last point is going to be doing the candidates test and actually circling the smallest as your min. So you have to do, some people like to set it up as, what do you need?
Nothing, just watching.
Okay. Awesome. So you're going to check endpoints and what? Critical value. So you got to plug it into the original function. So h of 0 is going to be 0 minus f of 0, which is going to be not that bad. Because if you go back to function f was this area collector function. What's the area from 0 to 0?
0.
0. So that's super nice. There's no displacement there. So that's just going to be 0 minus 0, which is 0. Then we're going to have 0 minus the area from 0 to 7. So now you're going to have to find some area under the curve from 0 to 7. Did we actually do that in part A? No, we didn't. So we'd have to actually figure out the area from 0 to 7. That's going to...
Yeah, right?
Yeah, 7 in there. Thank you. Okay, from 0 to 7. So that kind of sucks because I actually got to go back and find the area from 0 to 7 under the g of t function, which was what?
I got -5.
It is -5. That's
Yeah.
straight up -5. You were right. It was 4. It was 4. Is it 4 times x plus 1 to the...
Negative.
Is it negative 2/3? Was it this?
Yes, for sure.
Was that what it is? So then, remember, bring your 4 out.
10th graders, please meet in the studio this morning,
Okay.
10th graders to the studio. And if you're making up MCA,
Okay, so that's that.
we are
I
meeting
got mine
in
too.
room E.
All right, and then add 1 back to the exponent. It'd be x plus 1 to the 1/3, right? Divide by the new
Now.
exponent, so multiply.
And MCA's.
Evaluate it from 0 to 7. So you're going to have 12. So you have to do the work here, unfortunately. 7 plus 1 is 8, so it'd be 8 to the 1/3 minus 1 to the 1/3. So that'll be 2 minus 1 again.
It's 1.
So that'll just end up being 12 times 1, which is what?
12.
12. So you got that area under the curve is 12. So 0 minus 12. Why is it not?
What about this?
Oh, the start value. Yes. Why is it a start value of 7?
I don't know.
Why is it 7 minus that? That's correct. Oh, because I didn't plug in 7 there. Thank you. It's 7 minus, which she told me to correct a minute ago. So it's 7 minus 12, which is, that's how she got the -5. All right, and then finally, we already know h of 26. This will be easy. It'll be 26 minus f of 26. Did we not find f of 26 in part A?
Yeah, probably.
What was f of 26 from part A?
24?
No, I think it was it 9/2 or something like that.
No,
Was it 24?
that was a problem ago.
Oh, it is 24. You're right. Yeah, that was a problem ago. Good call. So it'd be 26 minus 24, which is what? 2. You want the smallest, which is the min, so which one's the min?
-5.
Negative at 7. The min occurs at 7, and it's a min value of -5.
Do you have to say min at 7?
What does it ask specifically? What does it say? It says find the minimum value. So you want to know the -5. The minimum value is the y value. The x is where it occurs. So if they wanted to say where does the min occur, you would say x equals 7. If they want to say what is the min value, you say -5.
Okay.
There you go. 3